All right, so last class or a couple of classes ago, you discussed topics of speed, velocity, and motion. Today we're going to take a look at three new topics. We're going to take a look at acceleration, forces, and net forces. So when we talk about acceleration, we're going to talk about a measure of the change in velocity of a moving object. Okay, so if you recall from notes from last class, velocity is a change in speed or a change in direction, because we know velocity as speed and direction. So direction needs to be given along with speed of an object. So when we look at acceleration, acceleration is a measure of the change in velocity of a moving object. Acceleration measures the rate at which velocity changes. Okay, so there's two components to velocity. You have speed component and you have a direction component. If either one of those, if your speed changes or if your direction changes, you are changing your acceleration, or you have acceleration. So velocity in turn is a measure of the speed and direction of motion, which we learned last class. So a change in velocity may reflect a change in speed, a change in direction, or both. Acceleration will be described with a direction because it represents the change in velocity, which is a speed with a direction. So lots of concepts that we learned last class that you need to make sure that you need to understand. So velocity, which is speed and direction, and you have acceleration, which measures the rate at which velocity changes. When we talk about acceleration, you might think about a car accelerating, or you might think about a boat, an airplane, okay, something that gains speed. So lots of people think that acceleration has to be an increase in speed, but a decrease in speed is also acceleration. So slowing down can be an acceleration. If you're in a car and you step on the gas and you feel your body move backwards because you're going super fast, that's an example of acceleration. But when mom or dad slams on those brakes, that's also a form of acceleration. So an object increases its speed when its acceleration and velocity vectors point in the same direction. So we talked about vectors last class. Those are your arrows that represent velocity, how fast something is going, and in what direction. So an object increases its speed when its acceleration and velocity arrows point in the same direction. An object will decrease its speed when you have your vectors pointing in the opposite directions. So when your arrows are pointing, one's going west, one's going east, your acceleration is going to change. And we're going to look at some examples of this here on the next slide. Okay, take a look at picture A. You have your velocity vector noted by the V and the arrows here, and you have your car moving to the right. When there's no acceleration, the velocity arrows stay the same size in the same direction. This shows a car moving at a constant velocity. So if you take a look at your arrows are exactly the same all the way across. This is showing you that your velocity of this car is constant. There's nothing changing. Your direction's not changing. Your speed's not changing. It's constant. So there's no acceleration. Let's take a look at B, picture B. Now we have a new vector. We have velocity vectors on the top here in red, and we have acceleration vectors in purple here. When the acceleration arrow points in the same direction as the velocity arrow, as seen here, both your velocity vectors and your acceleration vectors are pointing to the right, the velocity arrow grows larger. So this shows a car increasing its speed. So as noted in the last slide, if both of your vectors are moving in the same direction, you're going to have an increase in speed, okay? As compared to this picture in C, you have your velocity vector pointing to the right, your acceleration vector pointing to the left. So this is showing you that there's an acceleration, but you are now decreasing speed. So when the acceleration arrows point in the opposite direction as the velocity arrows will get smaller. This shows the car decreasing in speed. So you really need to pay attention to what your velocity vectors are doing and what your acceleration vectors are doing in order to determine how an object is moving. So there's an animation for you guys to look at here. You can take a look at that now, or you may take a look at that later on in after you're done doing the slides. Okay, so whatever works for you. So you can pause the video and watch the animation, or you can wait till the end. But let's take a look at this question. Can you think of an example of acceleration that does not involve a change in speed? So think about a car for an easy example. Think about what acceleration is, and think about when will a car not involve a change in speed? Let's take a look at the answer. So, driving at a constant speed around a bend in a road would be your answer to this. So it's telling you to think of an example of acceleration. We know acceleration is a change in velocity. We know velocity is either speed or direction. So if you're not changing speed, you need to be changing your direction. So driving at a constant speed around a bend in a road. If you go around a bend, you're obviously changing your direction. If this confuses you, what you need to do is you need to go back and make sure that you really understand what acceleration is, and make sure you really understand what velocity is. And then you'll be able to relate those concepts to this question. Okay, so a review for acceleration topic. I won't go over the answers here. These are something that you can go back and look in your notes to find the answers for. But you should be able to, after finishing this short video, be able to define what acceleration is. You should be able to describe an example of acceleration and explain how velocity is changing. And you should be able to answer this following question. The skydiver pictured will soon open her parachute. How will her velocity change when the parachute first opens? You may try and answer those on your guided notes, and you may check your answer with your teacher.